Introduction to Exercise 4C on Lines with One Intercept, page 229 of your textbook. For our do now question, we're sketching a line, a linear equation, right, based on the same concept we did in Exercise 4B. It's a lot easier to do this question if you just find your x and your y intercept. The thing with this kind of question is that you can see, well, it's probably got two intersections, right, or two intercepts. Basically, we're saying if I draw my axes, it should hit the line twice. So what I've done now is I've written out x-intercept and y-intercept, right? If I was to graph that out, it would look like this, right? Please make sure you're copying down this example as well. I know I've got x and y. My x-intercept will tell me where does my line hit that horizontal x line. And my y-intercept will tell me where does my line hit the y-axis, the vertical y line. So let's solve one of them. X-intercept, I let y equal 0. Kenta, can you just take that earphone? Thank you. So x-intercept, let y equal 0. I'm going to replace y with 0. And I get 3x plus 5. And you can write times. As a personal preference, I prefer to write brackets. There is absolutely nothing wrong with using times. I just personally prefer brackets. So we get 3x plus 5 times 0 plus, so equals 15. Of course, anything times 0 is 0. So I have 3x equals 15, which by this stage I'm hoping you, of course, recognize that if we divide both sides by 3, x equals to 5. Now, what does that look like on my line? X equals to 5. That means the coordinate is, because remember we said y equals 0, that means it's going to be 5, 0. Now, where is that? I'm going to say it's approximately here. The thing with sketching our lines is we don't need it to be exact. We're just approximating 5, 0. Of course, it's going to be on that x line. It's going to be 5 units to the right, so it'll be about there. We're going to do the exact same thing for our y-intercept, where we let x equal 0. So I'm going to replace x with 0. We get 3 bracket 0 plus 5 y equals 15. Of course, anything times by 0 is 0. So we have 5y equals 15, which, when we simplify, of course, y equals 3. Now, here's a mistake a lot of students make, and I'm going to show you the same mistake that a lot of students make. Okay, so we know the y-intercept is 3. Right, please don't write this down, by the way. We know the y-intercept is 3, which means that it's going to hit our y-axis at 3, which makes sense. So we go up by 3, and so we write here, let's say 3 is about there, we write 3, 0. Why is that wrong? I've done something wrong. Awesome. This right here says 3, 0, which means the x should be 3 and the y should be 0. But it's actually the other way around. So what you should be writing is the same point, but 0, 3. So the x is 0 and the y is 3. Because we haven't gone left or right any, but we've gone up 3 units. And then, in order to sketch it, we just need to connect the dots and a little bit further after that as well. Done. Any questions? I know it's a bit of revision from last week. Okay, let's move on to today's content. I'd like you to copy down what's in the blue for me. I know it's quite awkwardly positioned, but please draw down what's in the blue. With the graphs, you do not need to make them exact, perfect. You don't even have to include the numbers involved. Just the letters is okay. Okay? Now, the thing with the equations we were solving last week, or graphing last week rather, is that there are always two intercepts. Yeah? The line goes through both the x and the y axis at different points. That makes sense. But sometimes it only goes through one, whether it's because it's completely vertical or completely horizontal, or it perfectly goes through the middle, in which case it makes it very difficult to try and sketch our line with 2 points when there are only one. Or there is only one, sorry. So there are, and these are, I must say, are a little bit more rare You don't really see them as much in future, but it is very important that we recognize them. The first one is our vertical line. Now, the confusing part, right, is a lot of students think, well, vertical is the y-axis is vertical, therefore vertical should be y as equals blah, blah, blah. It's actually the opposite. With our vertical line, our x value never changes, does it? With this line right here, let's say, for example, b is 3. I don't know, we'll say 3. If b is 3, that x value of b never changes. It's always going to be 3. The y value could be negative a billion, it could be 0.03, doesn't matter. But our b value is always going to be 3. So our x equals to b, that's going to be a consistent, it is parallel to the y-axis. On the other hand, a horizontal line, right, because the y never changes, the height will never change. So it's always just going to be a number. So for example, c might be, I don't know, 2, might be 3, might be 4, we don't know yet. But if y equals to 4, that value will never change. The height will always be 4, doesn't matter what the x value is, which is why that's perfectly horizontal. So with our vertical line, it's x equals etc. And our horizontal line is y equals etc. The one that's a little bit more confusing, and just to be clear, you do not need to draw this big diagram on the bottom right. The one that's a little bit more confusing is when our line goes through the origin. If it goes through the origin, right, and like I mentioned, there's no second intercept for it to go through. But all of these lines, as you can see here, and we'll talk about this one next lesson as well, they all have slightly different numbers in front of the x. So for example, this one's obviously 1, there's 2, there's negative 2, negative a half, but they all go through the middle. Okay? The x-intercept and the y-intercept are both 0. That's pretty much all it's saying. So what does that look like in practice? I'll move this back later so you can keep copying the notes if necessary. Here are our examples. I'm going to very quickly sketch them, right, to show you what I'm looking for. That's pretty much it. I'm going to go ahead and sketch my axes. Let's start with the bottom one, because the bottom one's actually quite easy. X equals 3. With x equals 3, there's two ways I can do this. I can look at my notes and say, okay, well, x equals blah, 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 that's going to be a vertical line. Or I can say, well, x equals 3, that means that no matter what value of y, it's always going to be 3 across. So it's just going to look like this. Done. That's it. With our y equals to negative 1, no matter what the x value is, it will always be negative 1, the height. So, that's it. Y equals negative 1. No matter what the x value is, the height of the line will always be negative 1. Last one. If we're looking at y equals to negative 2x, okay, well that's a bit different. I know that, well, it goes through the origin. And the reason it does, and we know that, is because there is no plus c at the end. There's no plus 4 or plus 15 or whatever it is. It's just y equals to negative 2x. And copying my graph here, I know it goes from the top left to the bottom right. So it's just going to look like this. That's our y equals to negative 2x. Okay? We'll go through this specific number, what that means later on, right, in the next lesson. But y equals negative 2x, we can just copy this. If it's a very positive, we go to the right, top right. If it's negative, we go to the bottom right. That's it. Any questions? Okay. Just a quick question.